Good afternoon, everyone. Hope all is well. Hope everyone is doing all right. Hope you had a great weekend. So we are looking to get into chapter 4 today. All right. Also, I think I have videos for Wednesday to send to you guys, a lecture for Wednesday to send to you guys. My Friday had to end up having an emergency, so didn't get a chance to do it Friday or Saturday. Different things that came up, so I'll get that to you guys today. For anybody who was looking to review that lecture. Oh no, hold up. All right, there we go. All right, so let's look at 4.1 today. Maybe we'll get into 4.2 as well. Don't forget also, as far as chapter 4 is concerned, it's just 4.1, 4.2, and 4.3. So it's on 3 sections in chapter 4, and then we'll be out of it. So what we'll probably do is do 4.1, 4.2 today, maybe 4.3 next class, and then just leave it at that. Then that will put you in a position to be able to do test 2, which is chapter 3 and chapter 4. And then also, answer whatever questions anyone may have, with the time that's allotted. Or set aside since we don't have, I'm not, lecturing the whole time. But so scatter diagrams and correlation. Scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point. Give me a chance to write that before I scroll up. All right, so you have two variables that will allow you to plot on the scatter diagram. You have your explanatory variable and your response variable. And we'll talk about the differences in a second. All right, so the differences between the two variables, your explanatory variable explains the value of the response variable. The response variable is explained by the explanatory variable, or in other words, responds to the explanatory variable. So you see what we mean in a second when we put an actual example on it. But the response variable responds to the explanatory variable. Your explanatory variable will be X variable, response will be your Y. That's your domain versus your range, input versus output, and independent variable versus your dependent variable. Horizontal axis versus your vertical axis. And your explanatory is your predictor. Your response variable is your predicted. It's what you will be predicting. And here just showing you basically how your scatter plots will be plotted. You know, which is if you remember your XY axes, we were just using the first quadrant. So your explanatory variable is your horizontal axis, response variable is your vertical axis, and you're just using that first quadrant to plot your points. So this is, of course, generic. There's nothing that's putting those points there other than me just, dotting it up. But that's how it will look. All right, can I scroll up? All right, so linear relations is when a line best sums up the shape of the scatter plot. So the first two examples would be considered linear. The next two are nonlinear. And that final one is no relation at all. So that last statement, nonlinear does not mean no relation, just means no linear relation. So we look at the two middle values, not values, but two middle diagrams, the third and the fourth one. Not two middle, but the third and the fourth one. There's a relationship there, here and here, but they're not linear relationships. So basically, just making sure we understand it, just because you say there's not a linear relationship does not mean that they're not a relationship at all, just that's not linear. We need a straight line for it to be a linear relation. All right, next, associations. So positively associated is when one value increases, the other one increases as well. So you're reading your graph from left to right. If it goes up, then that's a positive association. So if it's negatively associated, when one value increases, the other decreases. So if you're reading your graph from left to right and it goes down, that means it's negatively associated. So you're always reading your graph from left to right. If it goes up, then it's positively associated. If it's going down, then it's negatively associated. All right, next we're looking at linear correlation coefficient. It's a measure of strength and direction of the linear relation between two quantitative variables. So we have Greek letter rho right here, kind of look like a P. You watch baseball, the Philadelphia Phillies have a P that's similar to this. That's Greek letter rho. That's the population correlation coefficient. Then just the regular letter R is your sample correlation coefficient. And notice in the red I wrote, this is the one we will use. So we will be using R, the sample correlation coefficient. All right, so in the blue, just like we did for the standard deviation and the variance, you want to find a calculator website or app or something of that nature that can produce the correlation coefficient for you. So once again, easycalculation.com is one that will work. So the correlation coefficient is 4.1, the regression line is 4.2. All right, any questions? All right, so let's look at a few properties of the correlation coefficient. So it is between -1 and 1 inclusive. If R is equal to +1, then a perfect positive linear relation exists. If R is equal to -1, then a perfect negative linear relation exists. All right, the closer R is to positive 1, the stronger the evidence of a positive association. The closer R is to negative 1, the stronger the evidence of a negative association. Rolling up. All right, so 6, if R is close to 0, then little or no evidence exists of a linear relation. R close to 0 does not imply no relation, just no linear relation. So we talked about that before.
I have a question. Is relation the same as correlation, or are those two different ideas?
Yeah, those are related. Yep.
Okay.
So what the correlation does, though, it gives us in one number, if it's positive or negative, so it lets us know whether it's associated up or down, so positively or negatively, and then also tells us the strength of the linear relationship. So yeah, it's all of that connected.
Okay, thank you.
Trying to look for. All right, can I scroll up? All right. So 7, it is a unitless measure of association. And then it is not resistant. And when we talked about that, if it's resistant, that means it's not affected by outliers. So this means that it is going to be affected by outliers. Right. Any problems? Any problems?
I have a question.
Mm-hmm.
So for unitless measure, you won't see it just written in inches or anything like that?
Exactly, right. All right, of course, if I scroll up too far, let me know. All right, so here we have a few generic examples of how the correlation coefficient reflects what's going on with your scatter plots. So you see the first one is a +1, and it's a straight line. And as you go to the left, it's going up. So that would be considered a perfect positive association. And then as we deviate or spread out from the 1 and go closer, we'll start to get closer to 0. So here, there's a little more spread in our data. That's why this is 0.9. A lot more spread gives us 0.4. And so I just wrote that arrow there to show that we still have a positive trend. It's just that we're getting closer and closer to 0. So that means it's not as close to the straight line as we would like. So here, -1 means that there's a perfect positive straight line, but it's going down, has a negative trend. And then as we move and start to spread our data out, even if we still have a negative trend, if it's not a perfect line, it's going to start moving closer and closer to 0. So arc, that would be 0 as well, or close to 0, because that means no linear relation. Does not mean it doesn't have a relation. There is a relationship here, which is an arc, but it's not a straight line. So that's why that would be close to 0. And then here's, just be close to 0, no relation at all, would be close to 0 as well.
Question.
Mm-hmm.
In the event that you have to draw a line in the scatter plot, would you try to draw it as close to the middle or where the dots are in the highest concentration?
Yeah. Yep. It would be more so. You would probably find like the dot that's down here, and then a dot that's up here, and then use those coordinates to create your line. I don't believe you guys are asked to do that, but if you were doing it on your own, you would take one dot that best summarizes, like maybe in the middle of it would be based on your discretion. And then from that dot, it will create a line that's like in the middle. So, yeah, I don't believe you guys are going to be asked to do that, but yeah. All right, any questions before we scroll up? Mhm. All right, so testing for a linear relation. I actually think this is the last thing out of this section. So we want to determine the absolute value of the correlation coefficient first. Find a critical value from Appendix A. Table, that should have been Table 2, Appendix A, or 8, Appendix A, Table 2. Anyway, I'll show you where it is in the book for the given sample size. And if the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two variables. Otherwise, no linear relation exists. So we're going to walk through those steps with a problem in a second. All right, scroll up. So the example we're going to use to walk through this process says determine whether a linear relation exists between the club head speed and distance. So we're talking about club head speed. We have a golfer that swings his club, to hit the ball. So we're talking about how fast that club is being swung. And then how fast that club is being swung will dictate how far the ball will travel once it's hit. And so that's why we look at the club head speed. That will be our explanatory variable. That would explain why the ball travels as far as it travels. The distance the ball travels is going to be a response variable. It responds to how hard it's being hit, or responds to how fast the club head speed is. Everybody done with the black? So we have 100, then 257, 102, 264, 103, 274, 101, 266, 105, 277, 100, 263, 99, 258, 105 is 275. And before we go to the website, each, this is one response. This is the second response. This is the third response. So we don't have, one, two, three, we don't have 16 different numbers here. We have 8 observations. This is 1, this is 2, this is 3, and so on. So we have 8 observations here, not 16 different numbers. So I just want to make sure we're clear. The 100 is attached to the 257 and vice versa. So you can't separate those two. Once again, you hit the ball. What this person hit the ball 100 miles per hour with the club head speed, and it went 257 yards. So that's one observation. Here's the second observation, and so on. So we have 8 different observations here. All right, can I scroll up? All right, so find the correlation coefficient. So let me go to, all right. So go here, correlation coefficient. Easy calculation or easy calculator. That's how I do it. You don't have to use easycalculation.com. I just know that's one that works. If you want to find the app, you want to use a calculator, it's up to you. It doesn't matter as long as whatever you're using is reliable and you test the reliability throughout your homework. You don't wait for the test, to try to figure this out. So in order to calculate the correlation coefficient, once again, I'm not asking you to know how to do it by hand. I'm not asking you to know the ins and outs of the formula. Find your app, website, calculator, something of that nature. Excel, if you can use Excel, you can, that's fine as well. So this one, that gives you the opportunity to add your rows, or you can take them away if you needed to. So you got 1, 2, 3, 4, 5, 6, 7, need one more, 8. And then you type in those values. And when you do these, make sure you double check, because if you miss one digit or change one digit, it will change the value of your correlation coefficient. So you do have to make sure that you do everything properly, double check. Yeah, should be a 2. All right, so calculate. And so here's our correlation coefficient. We have 8 numbers in total. Remember, I told you these are just 8 observations, not 16. And then here's our correlation coefficient. MATLAB will tell you how many digits they want. Normally they want 3 or 4. So make sure you're careful with that. Also, just like I mentioned before, if you miss one digit, let's say it's 274 instead of 275, notice we have a different number here just by moving that one digit by 1. So, make sure you're careful with your digits. Make sure you go back and review, make sure you have all your data values correct. All right, so before we go back to the notes, questions on what we did here. Very good, everybody straight. All right, close that out. All right, so that's how we got this number here, and I did 3 digits because that's what MATLAB asked for, 0.939. So now our next step is to take the absolute value of R. So they want the positive value. Whenever you take the absolute value of something, that will always give you the positive result. So that's what I was emphasizing right here. Take the absolute value of 3, the answer is 3. You take the absolute value of -3, the answer is still 3. So if you ever take the absolute value, that's what these lines represent, with the number in between it. That's the absolute value sign. If you take the absolute value of a number, that means you want the positive result. And so that's what I did right here. Because don't forget, your correlation coefficient can be negative. So we always want the positive result before we do our comparison. Okay, any problems with step 2? All right, so step 3, we're going to go to table 2 in the appendix, which is page A-2, and we're going to find a critical value. So I'm going to give you a second. I'm going to go there in a second, just give you a chance to write this down. I'll show you where it is in MATLAB. I think I have a copy of it somewhere to send to you guys, just in case, so you wouldn't have to go looking for them all the time. But yep, it's page A2, appendix, table 2. All right. So let's go to the page. So here you can either go to chapter contents or e-text. Doesn't matter. I'm just picking I just want to get to the book. All right, so here we go, and we should be able to go to search here, A-2. All I did was type A right here, but if I type A-2, I'll be able to hit it, but it came up right here. And there you go. This is the chart, the table. All right, so we have 8 observations. So our critical value is 0.707. Is everybody okay with that? So if I had 5 observations, then my critical value would be 0.878. I had 21 observations, 0.433. But once again, we have 8 observations, so our critical value is 0.707. All right, any problems? All right, go back to the notes. So that's how we got to 0.707. Now, step 4, we're going to compare the absolute value to the correlation, absolute value of the correlation coefficient and the critical value. So the absolute value of R, a correlation coefficient, is 0.939. Critical value is 0.707. So comparing the two, we see that the absolute value of R is greater than the critical value that we just pulled from the chart. All right. So since the absolute value R is greater than the critical value, then a linear relation exists between the club head speed and the distance. Questions. Oh, sorry about that. Any questions before I go to the next thing? All right. So that is 4.1. That's section 4.1. What I'm going to do right now is pause as far as lecture is concerned. We have a few people, a nice amount of people that need to actually get caught up. I don't want to keep throwing a lot of stuff at you, and a lot of us need to get caught up as far as our math lab assignments are concerned. Next class though, we will do 4.2 and 4.3. And once again, that's it for chapter 4. So I know a lot of us are behind. So please take advantage of the fact that I'm trying to slow up and not hit you guys with, too much stuff. Because really, in actuality, when you look at our timing, we could have done all of chapter 4 today. So trying to be cognizant of our situation. So with that being said, did anybody have any questions or anything? Anybody trying anything get stuck before we close out today? Anybody have any problems that they have a question on? Some of us just need to get in there and get rolling. So you may not have any questions as of yet. All right, so is everybody good? Like I said, if you missed early part of class, I had a few emergencies that occurred this weekend that prevented me from creating the last lectures video. I think I sent out one earlier part of the week, but I didn't send out Wednesdays. I don't believe so. Check that. Didn't get a chance to get to any of my classes because it was weekends events, but I'll get those out to you this evening. So I apologize for that. And I'll send this one as well. All right. So is everybody good? Everybody straight? Everybody know what they need to do? Everybody good? All right. So, all right, take advantage of this time. Let's get caught up, and I will see you on Wednesday.
Thank you.
All right. Take care.
Professor.
Yes, sir.
My apologies. I do have one question.
Mhm.
At the beginning of the curriculum, I think you mentioned that watching a video was part of our grading process.
Oh, no. I said that, well, I mean, at least I think this is what you're referring to. I record all of my lectures. And
Yes,
so
sir.
what I was mentioning that, as far as attendance is concerned, it's possible for you to miss class. And if you review the lecture, then it's the same thing as sitting in class. So I was saying I was taking attendance off of math lab. So I was saying for those who watch videos, and stuff like that, I wouldn't be able to determine who went to class, who sat through a lecture, who didn't. So really it's all about, I will be solidifying your attendance through math lab. And so that's the only videos that I will be sending to you guys is recorded lectures.
Understood. Thank you for clearing that up for me, Professor.
Yeah, not a problem, not a problem.
Good day.
All right, have a good one.
Sir.
Anybody else before we close out? All right, you guys have a good one. Take care.